Hello, welcome. And this stream is continuing learned following the exercise factor to him exercise. So before we begin, I just want to sorry that I wasn't able to because I else and then also working on the so I will be trying to more consider so will both sometimes work. Join me streaming. Now I'll add the handle demo. And talking about that, also I have the here. So feel free. So without further ado, let's get back to it. Today we're going to this exercise, which is 9 is about it. All right, so over here, let's get it. So we're saying is it let you express in the literals is hello? Oh, that's why. Yeah, my voice was a little bit low because I was moving away. So yeah, here goes. So Zig let you express integer literals in several convenience formats. So so this is basic stuff. So decimal, hex, oct, and binary. And then it also able to express as character because of it is an unsigned integer or 8 bits. So you can also place underscore, right, to help readability. I think in Rust do the same thing. So it is a improvement to make it a little bit easier because sometimes when you have a lot of characters, it's hard to read. So let's see. So Peace fixed the message. Sig is good. Huh? What do we want to do? So this will fail. It is an array. So this seems to be trying to print out Sig. So is it just because the character XYZ like that? because the number is incorrect. Yep. H I F G. So there you go. So it's just updating the binary. Although in this exercise, adding the number like this doesn't indicate the difference, because we are just adding a number. Is all from 1 to 2 and 0 to 1 and then 6 to 7. But in fact, because this is octal binary and hex, the exercise didn't show the difference, right? So when you, after 9, this would be A, and then B all the way to F, and then 7, 0, right? But of course, if we want to print out the word Zig, it is a little bit hard. And doing something like, you know, artificially making X8, 6, 5, 2 plus whatever to make the exercise work also looks weird. So it's okay. So set it back to 7 so that it passed. But just, you know, for those who don't know, the binary, you know, that's the different radix, right? So if you want to know more about it, feel free to just Google it, but it should be pretty obvious for programmer that this is decimal and hex is 16 base and octal is 8 base and binary is 2 base. So then let's go to the next one. Talk about floating points. Have support IEEE 574. So it support the 16-bit, 32-bit, 64-bit, and 128-bit. Right. So this is pretty basic. You have the scientific notation, and then you can do the underscore with .0, and the same thing over here. You can put a negative number. So hex float can use the letter E because that will mix with that. So we use a P instead. That's pretty interesting. I never thought of that. I wonder how it is in other language, or maybe the other language doesn't even support floating point in hexadecimal. So it's interesting. It would be something to take a look actually. So let's see. So floating point X. Right, so in the IEEE, compute. Let's see, if I copy this, too many hex digits. Does it work? No, it doesn't. So hexadecimal floating point. So format encoding. So how does different language represent it? Oh, it doesn't, you know, over here it doesn't talk about it. This just talk about in terms of math, how it is presented. I was expecting there was some session talk about how each language represented, or which language supports it. But seems like there's no such thing. Yeah. So everything I found after searching been how to use them. Why? C hexagonal floating, so C that supported floating point constant, then hexagonal distance operating in radix point, and then P. Okay, so in C it's already doing P, so that's something that I didn't know. So that's interesting. Okay, sounds good. Make it easy for compiler to reproduce the exact value. With decimal constant, there's some difficulty in converting a decimal number to binary floating point, because some value may be very close to a point when the value is round up or down. Okay, so to make it more precise, this is apparently a very long, long time ago. It's just that I haven't really worked on the system level stuff, writing C sufficiently to know about this. So cool, interesting. Let's get back to it. Be sure to use a float type that is large enough to store your value, both in terms of single-digit and scale. Round may or may not be okay. Yeah, that's, and also another interesting thing is when we're doing this, how do we know the size needed? I guess is over here, because say for example 16-bit, 16-bit allow you to have have 4 hexadecimal. I think I doing it right. So 8-bit is 254 256, which means you can do a two position hexadecimal, so 16 has 4. So the question is when it is floating point, because there's also the what exponent, what's it called? So these probably need a F32. Pretty sure it does, because you need something to encode this, right? Encode this number. So well, we'll see. So a floating point, it has let's go back here. Let's be sure to use the floating type large enough to store your value, both in terms round may or may not be okay, but numbers which are too large or too small become negative or positive infinite. So that it does that to avoid unexpected behavior, because when it is too many, I suspect how yeah, I don't know how C would do it. My guess is Rust will be the same thing, but I haven't looked into Rust on this topic, so I don't know if anyone knows over there. When you see the videos, let me know or talk about it in the Discord server. So I float literal has a decimal point when performing math operation with numeric literal. What's happened to my voice? What's going on? Excuse me, give me a sec. All right, does it sound a little bit better? Sounds like a dead frog. Wow. So a float literal has a decimal point. Okay. When performing math operation, we numerically ensure the type match does not perform type safe. 個依轉比含有 back. Right, both are float number, although when you multiplied it, does it go over the float 16? Because I really, the thing is, this is like, for me, it's like year 2000 stuff. That's when I was write a little bit of C code. I was having some good time with my friends to do a Yaloje program, which is the PS1 program. Try to write a game, and that's basically when I do C. And then later on, recently, about a year ago, I worked a little bit on some C stuff, but never really get into floating point. So this is completely over my head now. So I don't know if this has problem or not. I don't think this has problem because 13 times 0.5 times 5 should still able to fit in 4.16. So it's easy to determine. So let's see. Let's figure that out. So 13.5 times 5.0. Right, so let's see. So let's print that out because the example should show that this is also right an error. So lift off weight found 68, right? So 99, right? So well, 199. All right, so this will be still be fine. So when will this fail? So this will fail. Yep, infinite. Right, but that doesn't go to infinite. So I would say no problem, both are float. I'll probably add one line over here that do a calculation that actually shows that it will fail. It will not fail the type safety, but it will be a runtime error, or it will get to infinite over here. But again, I don't know what it be, what the number be, because I haven't do floating point calculation for decades. So I just raise an issue in the Ziglings repository so that Refactor can update this example. So to fix this, right, convert this weight to ton. We'll convert this weight from ton to kilogram at a conversion of that approximate weight of the space shuttle lift off was 2200 ton or 2200 ton, and then convert it using that by default format as scientific location. Right, so try implementing it to .3. Cannot be caused. I mix up something. Oh, so this is an example. Wow, okay, it's kind of hard to give out the answer. Well, I think we can, or it's placed over here. Okay. So this, it can detect that it fell because that number cannot convert to a compound int. Right. So what should we do here? Should we just change it to 32? No. Oh, no, because of that. Right, like that. So then now this is infinite. So we would need to change this to 32-bit floating point to do that. So that pass. Right, so try experimenting. So the .3 will have 3 digits. So you can see that over here, 3 decimal point, 3 significant 3 decimal points. So that's that. So floating further, as an example, have a half precision binary floating point format which store in memory like this. This example is the decimal number of 314, which happens to a closer representation of pi. Make it positive. So yeah, so this is talking about how it is implemented, right? So the exponent is actually taking 5 bits. So that is the standard that is described in the standard IEEE 754. So I to save space by modifying this value. The value is always subtracted from the exponent bit in our case, minus equal that, and so this is kind of like the zero component stuff. Significant digit become the decimal value after an implicit 1. So it's safe so it's, yeah, so that is really technical stuff, that it implicitly have a 1 down there. So if you look at the data, the value in memory, you would probably be confused of what it means unless you understand the standard. Right, so that is something that is quite far from me nowadays. Maybe, well, if I work on the just-func, I will need to go back to all this. So that is good information for me. And also, of course, for you, if you're learning Ziglings, for the sake of actually using it, this is something that you need to know. Or you should know, although most of the time I guess it doesn't really matter, because as long as you know about the, no, actually I shouldn't say that, because when it gets to floating point, it could get pretty messy, because yeah, that is a very deep topic. I know that it is a very deep topic, and I am not in any position to talk about it. So just leave it as is. And if you know about anything, like to share about anything, let me know. So that's floating point. Okay, so Next, cohesion. It will only take us a moment to learn the Zig type cohesion rule because they are quite logical. So it can always be made more restrictive. It cannot be loosened. So this, you can do that. You can from immutable to immutable, so that's great. All right, so this is possible because it's the same type. It's a pointer of the same. So numeric type can cause to larger type. So because it can fit, right? So so integer widening is called widening sometimes. The single item pointer to array calls to slice and many item pointer. So you just get a whole array and then take a part of it, right? Get a slice of it, or cast it to a pointer, right? Like this. So the single item mutable pointer can cause to a single item pointers pointing to an array of length 1. Okay, because mentally, let's see if I draw something. So because mentally, well, you have a number here over here. In this case, there's a 5 over here, and then you can create an array, right? We point to have array. This is the A5, and pointing to that with a size of 1, right? So that it allows you to do that. Okay, it's an interesting choice. It is an interesting choice. There might be not much harm of it if we remember the way that the Zig handles array. Let's see it over here. See if we can find it. Okay, array. There's a arrays over here. Right. Does it talk about how it was represented? Because I recall in the Rust, it's actually talk about how it is represented. So, but over here, it doesn't describe the internal working of it. So I actually should look up how it is done. So in Rust, there is it's something that you have an array of space, and then you have the length len, and then specify the size, and then that's about it. It's a very simple structure. I don't know if it is the same, and in this case, if it's able to cause to it, it's probably it does create this same structure, because if not, actually no, yeah, I think it will, because yeah, that although the language can make a special case for this, but I would feel like that could make the language, the internal working of it, pretty complex, So I don't know. That needs some further investigation. So do this. But yeah, it is interesting that it allows you to do something like this. So the payroll type and null cost, payload types and null cost to optional. So with that, so it's a maybe type. I see. So the payload can cast to optional. You can put null into an optional type. That is kind of obvious because that's how that's the definition of the optional type, right? So the payload types and error are cost to error union. So it's the same thing, right? These two I talked in the past. It is essentially the same thing, just different syntax. Undefined cost to any type. So undefined cost to any type, or it wouldn't work, right? If it is, because that the undefined, because I haven't worked on this for 3 weeks. So the undefined is basically you can use it when you are declaring the variable. So you can assign it to undefined temporarily until you assign the actual value. So yeah. So that's how it is. Compile time number cost to compatible types. That's obvious. And then also it works with the inference because in the compile time numbers, the compiler can determine what type it should be. Then it could validate and make sure that it can be cost to compatible type. So tag union cost to the current tagged enum. So it's the same thing. Well, no, I really shouldn't say it's the same thing in this case, because the tag union is a special thing that it can be assigned to a enum. There's an exercise over here. Right. Anyway, so enum cost to a tag union that when that tagged field is a zero length type. So what does this mean? To a tag union when the tagged field is a zero length type that has only one value. This not sure exactly what this means. That's probably, some exercise would be useful, would be beneficial. So 0-bit types like void can cost to a single item pointer. So because it's just a pointer, so you can put a nothing in there. That is kind of okay. Although I don't know how it will behave in terms of the type system, because when you're able to do that, how would it change? Would it cause issue? My guess is not. My gut feeling is not, but it's probably something that worth take a second look into it. The last three are fairly esoteric, but you are more than welcome to read more about them in the official SIG language. Yeah, so this three. Right. So over here now, unsigned 8 is a pointer, so you can point to U8, right? So, what? Huh? I don't have. Okay. So, just that. No. It's a pointer. It's a cons pointer. Unsigned 8 must cause from which is a pointer. Use rule 4 and 5. Use this. And 5 as an optional? Or probably either one. But why? My letter over here. Expect an optional type. Expect an optional type? Shit, What? Oh, what is this? Use cause rule. And letter must cause from and letter. Ah, that's interesting. Because it is a point. Oh, because it's a cons. So if I was doing not let what language I'm working on. Expect optional type. Does it mean because of downstairs is expect optional type? No, not. Hello? Yeah, unused local variable. So this is what this is fine. But when I'm assigning a pointer, getting a pointer to it, why it doesn't work? What? Because it's a variable, it's a mutable variable. Yep. So this works, right? Because when I'm doing this, the compiler knows that this not going to change it. So it's always it will always contain a value. But when I was when it was doing this, meaning it can be undefined. Right, so because it can be undefined, so then now these need to be a optional, but this still works. Right. This still works, but when we switch it back to a const, that now it is saying that. Okay, so yeah, that makes sense. That makes a bit more sense now, right? Because it's expect optional type. Why it is saying that is because down here, it based on the inference, it knows that we are using it as a optional. So because of that, this need to be a optional type. So like over here, And then is it like this? I forgot about the syntax again. Right, so yeah, because so now this is an non-array type. So let's do that. Right, so that actually make it pass. Right, that actually make it pass. Right, because this is a var. Right, so let's get deeper into it. So if this is a const, then I know well, I can do it like this. Expect type, but find const, or yeah. So because of that, because of it's a const, so that need to be updated because you cannot assign the const to a var, because that will screw things up, because the const is built in inside the program, is hard coded in the program. So that's why this has to be a const. So if we switch this back to a var, right, so it is in memory, so then the cost would still go through, right? That can be this can be done. So the thing really is, because of this over here have a optional, so because it's an optional, so the compiler knows that it can figure out the type. This is actually a optional stuff, so that it would need to do it like this. Right, you need to make sure that your type declaration match with how your usage is. Then the next things is further get this. So that's why it is using this to cast it to an single array, single item array, like that. Right, so now there's this pass. Although one thing is, why do we want to do this? Right, so this is okay. Well, this is a var, it's very common. You can declare a unsigned 8-bit as a var, obviously, and then you create a pointer, and because of this is a var, it can be optional. So doing this might make sense, although I could be wrong about that. But let's give them the benefit of doubt, because again, I haven't really do the system level programming for so long. So given the benefit of doubt that makes sense, then this makes sense. However, why we want to do this, and in this example it doesn't show. So it feels like, yeah, it's an exercise for the sake of exercise, right? So I would probably suggest adding some more description down here on why we need to do that, or point to some reference on why, you know, what is the actual use case for this. Because when we first look at it, right, it is interesting, but why do we have such case? Right, so with that, we are at 45 minutes mark. So the loop expression labels all this, let's see how long this is. This is not too long, so let's finish this one. So exercise 62. Right, so give a second, let me get it back to here. Okay, Exercise 62. Remember using if-else statement as expression like this. Well, yeah, it's the nicer ternary operation. I also let you use for and while as expression, which is nice. Rust have the same thing. So yeah, functional programming style. Like return for function, we can return a value for loop with break. So the break, yes, the break can return a value, but what value is returned from a loop if break statement is never reached? So we need a default expression. Yeah, okay. Thankfully, sig loop also have. So in Rust, just make sure that we are clear about that. So in Rust, it have the implicit return mechanism, so that you don't need to say return. Of course, you can. The other thing is you can just also use the return value in the Rust. So that's how Rust handle this case. You can just return it, if I recall correctly. I hope, right? If not, the implicit will work fine. I think it is, because it's nicely structured. It makes sure that you have the curly braces and all that. So yeah. But what value is returned from a loop if a break statement is never reached? Thankfully, we also have an else clause. So when I read to here, the first thing I think about is the unwrap or else in Rust. As you might have guessed, the else clause is evaluate a while condition become false, a for when it runs out of items. Right, so the for, I see, that makes sense. So else 0, and then else returns 0. This is a little bit weird, right? This actually, both of them still is a little bit weird to me, because if you do not provide, let's finish the reading first. If you do not provide an else clause, an empty one will be provided for you, which will evaluate to a void type. So the kind of like the implicit return, but it's just returning nothing, which is probably not what you want. Consider else clause is essentially when looping as expression. The else, because the thing is when it is a single liner, so let me try to adjust it over here. So if I were doing, if it can be done something like this, then yes, that looks a little bit more okay, right? Because then the value, the variable in scope can be accessed through in both the break case and the else case. And here in the for case, I assume the f can be accessed in the else case, but you can see that when we read this, it might need to get some time to get used to it, right? So yeah, it will probably need some time to get used to it, because when I read this, you could see that this get the access of f, but not the else case. Yeah, so that's language. So we create an array, and so let's find the first language with three-letter names, three-letter name, and return it from the for loop. So for this, so we get the lang. So it breaks. How do we say that? Oh, that's this if. If that is that, else here. So let's find the first language. If length equals to, return it in the for loop. Else, and let's say lang. yeah, that's the problem I'm talking about. So when it is this is within the scope, right? So how do I can do a void? So this, it has implicit else void here. So this expect a cons return nothing, because it's a an array of character which is a string, right, like this. But current language SIG did not find a free character. So the current lang over here, so that is caused to false, right, over here. So meaning, if I putting something here, that will definitely, of course, it will fail. Oh, it doesn't fail. It just returning something. Returning that did not find a free character. So let's make it no, there's no free character. So then it will show prologue, right? When it is empty, right, it will show empty. So the question is, well, okay, so, okay, I got it. So number one is because in case for a for loop, well, I now I understand. So because in case of a for loop, right, if you're able to return in mid-range, then it makes sense to access the value at hand, right? But if it doesn't return anything, it goes to the end, then it would need to return some sensible default, and by that time that go, obviously that go out of scope, right? And it makes sense to not able to access the variable, right? What am I talking about? Right? So that all makes sense. So this just returning some default value. My question, well, in the in SIG, this is a iterative is an iterator, right? It's a for in loop, not the typical index-based for loop, right? And the same thing for the, well, essentially the same thing for the while loop. So there's no additional information that we can get outside from the for case. So yeah, so it really just go out of scope and then return some value. So I wonder, I feel like this is something really extra. This is really something extra in now as I look into the if I think it through, because if it is always optional, then having an optional I don't know if this is really a good good thing or not. I don't know, really don't know if this is a good thing or not, because in one hand I can see that it makes it a little bit more convenient to define the else case, On the other hand, I also thinking, well, if it is a optional type, right? Oh, well, it is. Okay, now that makes sense because in Zig, the optionals, so go back here. Yeah, that's the thing. Here, in the optional type, you have this or else, right? So this is optional. So the result over here, right? This is the optional default. It's an optional type. And then in the optional type, you have this or else case to say that when it is no, right? When it is nothing, then you will use this. So if I were designing this, I would say this should be for else to make it consistent, because this the for loop and the while loop by default, because the construct is saying that, okay, when you go out of scope and you're not returning anything, what are you going to do? And so that leads perfectly aligned to say that it is returning an optional. And so when it is returning optional, I would say that it should use the same syntax as a optional type. Just treat this whole thing as kind of like an anonymous function, and then you evaluate it right there. Then this is and then this get the result, and then you just use or else. Right? That's what I would do. That's what I would do. And no, it doesn't work. Of course, it doesn't work. That's how the language is defined. So so it have to use this else case, right? So let's fix this, change this back to get the exercise pass. But yeah, so I think this is a missed opportunity. Yeah. If I were designing this language, I would say this should be or else to make it consistent with other optional type. Right. So, but anyway, we're just here to learn about the language. So it is what it is, and it's just something that we need to be aware of. Right. So that's that. All right, so with that, we are hitting the 1 hour mark, and I think it's a good time to stop this stream. And so hope you enjoyed this, hope you learned something. And I definitely do. I haven't really worked on the floating point for decades. So pardon me if I was struggled pretty badly over here. And then on the cohesion on this three, this is definitely something that would look worth take a deeper look into it, especially for me. I still haven't get my head around this, the enum cost attack union, what does it mean for this these things. So that would be something interesting to follow up. And I literally ran that this exercise, it served the purpose to demonstrate those two rules, the rule 4 and 5, but would like to know why, in what use case that this is this would be useful, right? Because there got to be a reason that the language was designed in such way that have this rule, right? So and the last point is right in the loop expression, right? As I mentioned, right, this else is okay, but it probably should be or could be better if it is or else to make it consistent with optional types. So that's it. So that is it for this stream. So if you like the stream, feel free to hit a like and subscribe. And if you don't like, you also feel free to do a dislike. And If you have any suggestion, any comment, feel free to add it in the comment section down below, or join the Discord group so that we can chat. To talk about Ziglings, talk about all the open source project that I worked on, about TypeScript, about React, about architecture, or testing, anything that you find interesting. So that's it for this session. So we'll see you next time. Bye bye.